Hi everyone, welcome to Cloud Computing series. In this video, we'll be learning about the next important question of Module 2. That is, discuss how CPU and memory virtualization is performed in a cloud environment. See, a virtual machine works just like a real computer and it runs applications and operating systems inside a virtual environment. And most of the time, virtual machine instructions run directly on the physical CPU without any changes. This makes it fast and efficient, almost like using a real machine. And types of CPU instructions in a virtualization. The unprivileged instructions. These are safe instructions. They can be executed directly by the virtual machine. No special handling needed here. Then privileged instructions. These are sensitive commands like changing system settings, and they can only run in a supervisor mode. If a virtual machine tries to run them, they are trapped and handled by the virtual machine monitor or a VMM. And then control sensitive instructions. These change the system configurations like a memory layout or a device access. The virtual machine monitor needs to watch over them carefully. Then behavior sensitive instructions. See, the behavior of these instructions depends on the current system state. For example, how memory is accessed might change depending on how the system is set up. Moving to the next. This diagram shows how Intel's VT hardware assisted virtualization allows a multiple virtual machines, each running its own operating system and apps to run on a single physical computer. Yes, a special software called the Virtual Machine Monitor manages these virtual machines by handling a memory, CPU, and input-output operations. The Virtual Machine Monitor works in a special CPU mode called VMX root mode and uses a data structure called VMCS to control when a virtual machine starts or stops. This setup allows efficient and secure virtualization by using Intel processors with a built-in VTX support. Then next is CPU virtualization. See, a CPU is considered virtualizable when its privileged instructions can be trapped safely if run in user mode. This means if a normal program tries to do something only the OS should do, the virtual machine monitor steps in and handles it. And the virtual machine monitor runs in a supervisor mode, that is the most powerful level, and it controls sensitive operations to keep the system secure and stable. Then reduced instruction set CPUs like a ARM. These are easy to virtualize. Why? Because all sensitive instructions are privileged, so they always trap correctly. x86 CPUs like Intel, these are harder to virtualize. Some sensitive instructions like a SGDT or a SMSW don't trap in a user mode. So full virtualization is not possible without hardware help like a Intel VT or a AMD V. The system calls in a virtualization on a normal system. When a program makes a system call, it triggers an interrupt int ATH, which passes control to the OS kernel. The next is on-para-virtualized systems like a Zen. See, when the guest operating system makes a system call, it triggers int ATH, and at the same time, int AT2H goes to the hypervisor. The hypervisor processes the call, then returns control to the guest OS. Yes, also the guest OS can skip this and make a hypercalls directly to the hypervisor. This is faster and more efficient. Moving to the next, memory virtualization. See, memory virtualization allows multiple virtual machines to share the same physical RAM in a safe and efficient way. The next is comparison with the traditional OS. In a traditional operating system, there is a one-step mapping. The OS maps a program's virtual memory directly to the physical memory using a page tables. Then in a virtualized systems, see, In this, memory mapping happens in two stages. First, the guest operating system maps virtual memory to the guest physical memory. Then, the hypervisor maps this guest physical memory to the actual machine memory. Why it's important is this layered approach keeps each virtual machine isolated while still sharing the same hardware, enabling a better performance and resource management. The next is role of memory management unit. See, the memory management unit is a hardware part of the CPU that handles address translation, like converting a virtual addresses into physical addresses. Then modern CPUs also use a TLB, that is translation look aside buffer, to speed up this process by caching recent address translations. See, in a virtualized system, the memory management unit must support virtualization. This happens in a way that's invisible to the guest OS. The guest OS thinks it's in a full control. Yes, responsibility of guest OS. See, it maps memory for its own applications, just like in a normal system. Virtual machine monitor or a hypervisor, it actually decides and manages how real machine memory is allocated to each virtual machine. The next is, yes, see, this diagram shows how memory is managed in a virtual machines using a two level of mapping. Each processes inside a virtual machine, like a process 1 and 2 in a virtual machine 1 and 2 uses its own virtual address. First, the guest operating system in the virtual machine maps this virtual address to the guest physical address. Then the hypervisor takes that guest physical address and maps it again to real machine address in an actual hardware memory. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for a more insights on a cloud computing, and also check out our playlist for a more in-depth topic. See you in the next video.